Hello friends, welcome to Tech Greens, and in this edition of Mastering Hadoop File System, today we'll discuss one of the storage formats, ORC, in detail. So this video is about ORC internals. So let's see guys, what is ORC file format? So ORC stands for Optimized Row Columnar File System. So this is the file system now maintained by Apache. Initially, it was developed by Hortonworks for the Hive ecosystem, and this was primarily developed to overcome and give the additional performances on top of the existing Hive file systems, which was RC file system, row columnar file system. So to have a better optimized performance with the Hive processing system, ORC was developed. Now, this is a de facto preferred format with the Hive processing, and why it works, gives better performance with Hive is because Hive has a vectorized ORC reader. Guys, vectorized ORC reader means they have a system which can acknowledge the indexes, the lightweight indexes which are developed and written with the ORC file systems. So Hive has written a system which can acknowledge those indexes, read those indexes, and thus results in better performance with ORC file system. Now guys, with ORC what happens, uh, ORC always produces a single output out of each task it performs during the processing. And when we'll have single output of each task, it reduces the load on the name node, because name node keeps the track of all the output files, keeps the metadata of all the output files in the Hadoop world. And if you would have only one file produced out of each task, the load on the name node is reduced, and thus retrieval from the name node, metadata retrieval to do any kind of read and write on the Hdfs would become faster. As we've already discussed, the ORC file format facilitates lightweight indexes which are stored within the file itself. And as these indexes are stored within the file, Hive has written a vectorized ORC reader which can acknowledge these indexes and increase the performance with reads and writes. So guys, this is primarily what is ORC file format. Just to quickly reiterate, ORC stands for Optimized Row Columnar File Format. It's one of the storage formats with the Hadoop systems. It is also columnar oriented, so that data for a single column across rows would be stored adjacent to each other on the underlying disk or file system. ORC is primarily meant for the Hive processing engine because Hive has given a vectorized ORC reader. Now let's move forward. Now on this slide, friends, we'll discuss the internal details of the ORC file format. When we say internal details, this means when that file, which is of the format type ORC, is actually stored on the disk, what are the different components and elements of that physical file. So ORC file contains primarily three component sets, or we can say elements. First is the stripes. Stripes is primarily the row data. So there would happen the grouping of rows, and that will form one stripe. We'll see in detail in the coming slides. Now the second element is the file footer. File footer is comes in the end. There could be multiple stripes based on how the row groups are maintained for a single file, but there would always be a single file footer which primarily contains the additional or auxiliary information, like the list of stripes in that particular file. One particular file could have a number of stripes depending how the row data is collated. Second information it keeps uh, information about the number of rows per stripe. So primarily guys, file footer keeps the metadata of the stripe. that how many stripes are there, what are the number of rows in each stripe, what is the data type of each column, and it at the same time it also keeps some of the column level aggregates like counts, min, max, and sum, so that like what is the minimum row count in a particular stripe, what is the maximum row count in a particular stripe, what is the sum of rows in that particular stripe, count of rows in that particular stripe. So all these metadata information about a stripe is kept in a file footer. And the last component in the ORC file format is the PostScript. PostScript primarily keeps the compression parameters, and it uh, kind of gives you the information that what are the different parameters which would be taken into account when the block level compression will happen in the ORC. As we have already discussed in the previous slide, ORC file format supports lightweight uh, block level compression, and that and all those parameters and information about the compression is kept in the post PostScript. And this PostScript, like with the file footer, is kept towards the end of the file. So imagine the ORC physical file structure is there could be n number of stripes, and towards the end of the file there would be one file footer carrying the metadata information about the stripe, and there would be one PostScript which will have the auxiliary information about the compression parameters. In the next slide we'll show how exactly the ORC format looks like, the physical structuring of the ORC file. Just two more quick pieces of information here. The default stripe size is 250 MB, and there's a reason during the design process of ORC file system to keep this size little large if you compare it with the Hdfs block size, which is 128 MB. It is almost double of that size, and the reasoning behind that is that large stripe size will enable efficient reads from Hdfs, right? So that is the thought process to keep the stripe size almost double of the block size in Hdfs world. Now guys, this is the picture how ORC physical file look like. As we've discussed, it could have multiple stripes of default size 250 MB, and each stripe would have their own internal components which we'll discuss here. But if you look at the picture carefully, you will see that this is one file which is shown. It has got number of stripes, and towards the end of the file it has got one file footer and PostScript, right? And if you'll see, each stripe has got the information about all the columns, right? So that because as a system it's a columnar oriented structure, so it will carry the information about all the columns in the stripes, right? Now let's see what are the different elements, or what are the different things a single stripe contains. A single stripe contains index data. It contains row data, which is nothing but your data in the rows across all the different columns, and it would have one stripe footer. A stripe footer will also carry the metadata information about that particular stripe. We'll discuss all these things in detail in the next slide. And as we have discussed, at the end of the file there would be one file footer and PostScript, right? So this is one example that we can take, that how if we'll put some data into the ORC format, how it will look like, what would be the physical representation of that data. So here is a table which has got three columns: ID, name, and state. And if you see the first at the top, that is your strike index, and if you see, it has got the index information, index data. If you see at the top of the column like ID, below that you will have like min max values, that is the index data for that stride. It also includes the row positions for all the different rows making part of that particular stride, right? As you have seen in the previous slide, One particular stride carries three elements: index data, row data, and the stripe footer, right? So if you can see in the table picture which I've shown here, if you see the ID, the index data for it is the min value 1, max value 10,000. Similarly, the row data for it is, 1 for ID, name is Bob, and state is NJ. So like this, there are three rows. Uh, though here we are just showing the three rows, but we are saying that this stride actually contains 10,000 rows. So that is making a component construct for one stride. And similarly, with next 10,000 rows, it will make another stride, right? And these size are taken on the fact that stride has a default size of 250, so it cannot go beyond that. So last element in the stride comes stripe factor, stripe footer. Stripe footer actually contains a directory of stream locations. Stream is nothing but your serialized data, like whatever the data you have got in your table, whatever no whatever would be the serialized representation of the data, that is called stream, and stripe footer contains the directory of those serialized data locations, right? Now let's see here. Now again, we'll discuss the details of a particular stripe. A particular stripe, as we have discussed in the previous slide as well, carries index data. Index data primarily contains the aggregate things like min and max for each column and the row positions within each column, right? Row data, as we have seen, row data is a collection of rows which are making part of that particular stripe, and stripe footer contains the directory of serialized data locations, right? Now, in this particular slide, I have mentioned the list of ORC configurations which could be configured externally to change the behavior. Um, this you can use for your reference. Some of the things I can discuss from this configuration list is like, if you see the third row, it is orc.compress. So here you can configure ORC format to use the compression algorithm, or to not use the compression at all. You can use none. So in that case, when the file would be stored as ORC, there would not be any compression. If you'll use Snappy, it will be compressed using the Snappy algorithm. Like for example, if you're trying to create a table in the Hive system, and we want data to be stored as ORC, and we want that there should not be any compression, this is how we can do. We can use table properties attribute and use this configuration parameter orc.compress and pass the value as none. So it will create a table. The table will store the data with format as ORC, and there would not be any compression. Similarly, we can use other configuration parameters and tweak the behavior, how the ORC format would be stored. Now, another important concept with any of the storage file formats in the distributed systems would be your serialization. As we know that when the data would be processed in the distributed system, uh, data may need to move from one node to the another over the wire. So we need a mechanism to serialize and deserialize the data. So serialization in ORC is actually dependent on data type. This is very much interesting. So here we have made in the ORC file format systems, serialization depends on data type, and and the entire categorization of data types from serialization perspective is integer versus string, right? The serialization on integer column is done as a stream of integer values, right? And the serialization of string column uses a dictionary mechanism to form unique column values. Uh, and there is a specific purpose why they are using dictionary mechanism, because the dictionary that they create with unique column values, first of all, it will not keep the entire value set which would be redundant. So dictionary will only contain the unique column values, right? Suppose we have 10 columns, and in those 10 columns if 5 values are repeated, right? Then when we'll create a dictionary, it will only have the 6 unique values, right? So it will help us in keeping the storage lean. And when we'll keep the dictionary storage lean, our lookups would be faster. And on top of that, how the ORC keeps the dictionary, they keep it in a sorted way. So that increases the lookup even faster. Now the another important factor which we've also discussed while we have seen how table properties and configuration could be used to apply compression on ORC storage formats. Let's see uh, how exactly and what are the different compression paradigms provided by ORC. So in ORC, as we have seen earlier, compression codecs could be defined as part of the table properties. While creating a table, we can use the attribute table property and define whether we have to do compression or not, or if in case we have to do the compression, which algorithm to use, zlib or say snappy. Uh, an interesting technique used by ORC to optimize the memory utilization is compression is done incrementally as each block is produced during processing, or say while persisting that bigger file. Compression is done incrementally. It is not done in one shot. So you can imagine the benefit of it. So if we're talking about the big data systems here, and say we have a 20 terabyte of file, and if you are say trying to persist that file into through say Hive system into some underlying distributed file storage, and we're trying to compress it, say, and say compression is happening say on the entire file in one shot, there will be a that for that we'll have to bring the entire data into the memory, so that will crash the memory. That's not possible. So here they use the mechanism to incrementally apply the compression, right? So this is a pretty interesting fact about ORC file systems, and as I've already discussed, the different algorithms, what we call as compression codecs in the terminology, available with the ORC file systems are snappy, zlib, or say none. None means there would not be any compression, right? So guys, that's all about ORC internals. I will quickly reiterate some of the important points. ORC, it's a columnar oriented storage format. It stands for optimized row columnar file system. It is primarily developed for Hive systems, as Hive has got a vectorized reader for OLC5 formats. The reads and writes and processing of data is faster uh, with Hive systems if in case the file format is ORC. We have seen serialization in ORC. Serialization is based on the data types, where we differentiate how the serialization would happen on integer versus string. The compression codecs available with the ORC formats are snappy, zlib, or none. The internals physical structure that we have discussed for ORC has primarily got three components. One is your stripes, then uh, comes your file footers, and then your postscripts, right? File footer carries the metadata information about the stripes, aggregate values, list of rows, row positions, and things like that. While your postscript carries the information about the compression parameters. The default size for single stripe is 250 MB, and there are three elements inside a stripe, which is your index data, your row data, and your stripe footer. So guys, that's it for the ORC file format internals. Thanks for watching. God bless you all. Keep watching and do subscribe to my channel. Have a good day. Bye bye.